Hello, everybody. Hello. So I'd like to introduce you to Grant Jenks. After 5 years at Microsoft as a compiler engineer on the Midori OS incubation project, Grant founded an ad tech company and applied his expertise in distributed systems and machine learning to predicting search engine rankings. You can follow him at Grant_Jenks at Twitter. Please welcome.
Thank you. Hi, how's everyone doing this afternoon? Woo! Are you feeling that? Like, did the cake sugar kick in yet? You have some energy? How many people currently have a job where they are paid to write Python? Woo! How many people would like a job where they are paid to write Python? All right, that's excellent. My name is Grant Jenks. You'll find me on GitHub. You'll probably find me on Twitter, but I don't really use it much, so don't go there. GitHub, email. Let's go ahead and get started as soon as this works. Let's see. Nope. Yes, OK. I recently did a ton of interviewing. I reached out to 21 companies, and 8 completely ignored my application. 2 rejected me just based on my resume. They're like, yeah, you're not the right fit for this job. What I learned in that whole process is that it's all about referrals. Having someone at the company submit your resume to the internal black box that runs recruiting, that's how you're going to get your foot in the door. Throwing your resume into their submission site, into whatever thing they use to catch resumes, very unlikely. 11 of those companies brought me on site for interviews, and 2 rejected me based on interviews. So I'm at like 9 for 11. I interviewed at Facebook, Amazon, Apple, LinkedIn, Google, pretty much all the big companies. Didn't get that interview at Netflix, didn't get to interview there. 9 of them made offers. And it was an enormous undertaking. I mean, it was exhausting. I was incredibly methodical about it. That's just my nature. I ended up doing over 145 practice problems in preparation, and that's about 4,000 lines of code. And I ended up joining LinkedIn in July of 2019 as a staff software engineer. LinkedIn, woo! Yeah, there you go. Yeah, Barry's here. When it comes to interviewing, you'll find a ton of articles out there online, right? I typed in interviewing is to Google. It said it's broken, it's exhausting, it's hard, it's stressful, it's a two-way street. It's an art. I was like, wow, it's an art. Some people, they develop this attitude, interviewing is the worst. And I sympathize with that. But I think that's actually kind of a bad attitude. And other people who are really good at interviewing, they say, don't hate the player, hate the game, man. And it's like, yeah, that's so obnoxious of you, though, because someday you're going to fail, right? Like, nobody aces all of these. I think the best attitude we can take is really to try and forgive the system for what it is. It is full of broken things. It is a painful process. It's actually pretty challenging for your interviewer as well. Like, I've yet to meet a coworker that's like, I love interviewing, man. Such a good use of my time. So awesome to meet people, right? You're kind of in this situation where nobody wants to be there. The last time I had that experience was when I was a prison support coordinator, and I would visit people on death row, and like nobody wanted to be there at the prison. And I was like, yeah, this is my flashback to what it's like for interviewing. Like, this is what it feels like. But here's why you should get really good at it. This is the real kicker. The upside to being good at interviewing is incredible. If you make an extra 10K per year, then over the lifetime of your career, that will accrue to millions. I know we have talks here about machine learning, and they're talking about DevOps and websites and stuff. All of that is not going to make you a little bit richer. This is going to make you a lot richer. Like, this is why you're here for this talk today, I hope. It turns out Python is an ideal language for many coding interviews, and Python was my tool of choice. I'm an expert in Python and C++. There's a lot of people that'll tell you, oh, you should go with C. It's got pointers. That's the way to go. No, don't do that. Use Python. Python is awesome. Before we get too far into the algorithms kind of stuff, I want to just review a couple of core Python features for technical interviews. The first is, of course, the built-ins. Like, these are table stakes. You know, you need these just to have a working knowledge of the Python API, and I think you should actually have a deeper knowledge of how they're implemented. Broadly, Python's data types fit into 3 categories. There are sequences, there are mappings, and there are sets. If you look down at the C API, it's actually codified that way. If you go to the collections module, it's got the ABCs. Those are abstract base classes. It is designed for you to register classes in one of these 3 categories. Now, sequences are laid out in memory as a continuous array of pointers or data. So it's very easy to reason about them. If I wanted to know the length of this continuous array, that's going to be a really fast operation. It's allocated there in memory. If I'm going to do a lookup, that's also going to be really fast because it's statically allocated in memory. The range one is kind of an interesting one here. Range doesn't actually build this whole continuous array in memory. Instead, it just computes things based on offsets. So you say, hey, range 10 to 100, steps of 10, give me the third one. It goes 3 times 10 is 30, plus 10 is 40. Boom, there's your answer. So it's all kind of this mathematical thing. But it implements the sequence API. Similarly, the dec data type is a doubly linked list. Means it's optimized for adding nodes at the beginning or the end of a doubly linked list. It's incredibly fast for that, and it implements the sequence. The caveat is that doing a lookup is going to take a bunch of time. Most mappings are containers of key and value pairs called items. The keys are indexed by hashing. Similarly, we have sets. One of the surprising things, because you can hang attributes off of objects, you don't really need mappings. If you just throw objects into sets, and then you look at what's on the attribute, like you look up what's hanging off the object, you could get away without using mappings. Don't do that, though. That's just a crazy idea. One of the best ways to learn these things is to actually dig into the standard library. And the way to dig into the standard library and learn from it is a little tricky. The standard library does all kinds of things to support a broad set of use cases that you won't do in normal programming. So be careful as you read the source. But I would absolutely recommend you read the docs pages for the built-ins. Like, Python's docs are actually pretty good. You got to read those. That's how you get started. Type in the examples you see there. Make sure it works on your machine, and then use them in your code. At one point, I had all these slides that was talking about the big O runtime complexity of these different things, and it was boring, like really boring. And I was reminded of that saying. Anybody ever heard this? If you give someone a fish, you feed them for a day. If you teach someone to fish, you feed them for a lifetime. Here's my big O trick. This will feed you for a lifetime. Measure. Did you get it? Super simple. Just try it out. Try it when n is 1,000. Try it when n is 100,000. How much worse did it get? That's your big O. So what we see here is that when a list is created from 1,000 elements, it takes 17 microseconds. When a list is created from 100,000 elements, it takes 2.52 milliseconds. How much slower did it get? Roughly. It's 100 times slower. N increased 100 times, it's 100 times slower. That tells us it's linear. Notice that when I create a range of 100,000 elements. This is an enormous range. Is it really fast? It takes 300 nanoseconds. Doesn't matter how big the range is, because ranges compute these things. Best way to figure out big O is to measure. Once you figure out this trick, you want to sound really smart. So you don't call it big O. You call it asymptotic runtime complexity. That's your SAT word here. The good news is IPython, interactive Python, has this fantastic timeit magic command, and that'll go ahead and call the timeit module for you. It'll go and calibrate things. It'll turn off the garbage collector. Lots of best practices there. That's how you should get started. For the most part, in the standard library, all you need to know are 2 runtimes. Order 1, that's super fast. Order n, that's linear. Almost all the operations of the built-in types in the standard library are order 1 or order n. When it comes to identity and comparison, you should know that Python stores things in memory. Memory has an address, and you can actually ask CPython for that address. That's the ID of an object. So we see here A is stored at address something something AD0. B is stored at address something something AF0. And if we ask whether A and B refer to the same thing, that's false. But if we ask whether they're equal, meaning are these the same number, that's true. And you can customize that behavior through Python's dunder methods. That's the dunder EQ method. And then as part of the mapping and set data types, they're going to use the hash function. So hashing is implemented with dunder hash. You can hash strings. You can hash numbers. Those things will be critical if you're going to overload them, but you probably don't ever have to do that in a programming interview. The last one is called lexicographic comparison. And lexicographic comparison is one of those SAT words, which means it's just like how you would expect. Meaning, when you go to look up a word in the dictionary, which word comes first? Apple or banana? Apple comes first. Why? A before B. How about apple and aardvark? Which one comes first? Aardvark, because if you compare the first one and they're the same, then you compare the second one. The fancy name for that is lexicographic ordering, and that applies to all sequence data types. Strings, lists, tuples, decks, ranges, they all use lexicographic ordering. All right, those are our table stakes. That's our foundation. When it comes to algorithms, you're going to have to solve some kind of puzzle. And that's usually where people groan, right? Because hanging in the balance is your career and like hundreds of thousands of dollars and a whiteboard where you'll have to go through this trial. We're going to look at 10 different types of algorithms together. The first one is my favorite, the brute force algorithm. I actually had to think for a moment, how do I create the worst sorting function of all time? It is this one. This tries every permutation of the input values, looking for the first one that orders things correctly. And when it finds that one, it goes, boom, I found it. Worst sorting algorithm ever. You should totally use this in an interview. Be like, this is how I sort things. You thought bubble sort was bad. This is way worse than bubble sort, right? This comes out of itertools. Itertools has a whole bunch of useful things. Permutations will try all the different orderings, all the different permutations for you. My other favorite is itertools.product. It'll go ahead and try all the combinations of all the different things you give it. So if somebody said, hey, how do I know all the words that could be spelled with this telephone number? You'd say, well, let's see. For each digit, it maps to a certain number of characters, and I want the product of all those characters and look up each one of those in a dictionary. That would be a quick way to get started. Oftentimes, as I interviewed, I wrote down the terrible solution first. I said, hey, is this kind of what you're looking for? Like, I know it's slow and it won't work at scale, but is this is what we're driving at, right? So if someone said, how do you sort things? You might say, well, we'll try all the different permutations. This is brute force. It's my favorite. The second one is greedy. Now, I actually am a very greedy person, so I should like this one. But greedy typically is going to use either Python's max or min function. And fundamentally, what a greedy algorithm says is that each independent state, each intermediate state, make the best choice you can make at that state. And when you do that over and over again and you get to the end, you'll have made the globally best choice. So the idea is that in order to make the global best choice, you make a whole bunch of best choices at intermediate state. My other favorite one here is that you'll notice I'm using recursion, right? So I'm trying to find the maximum tree height. And the trick with recursion is that in order to understand recursion, you must first understand recursion. If you want to move beyond max and min, you have more than a couple of things, you're going to reach for Python's heap queue module. And the heap queue module implements the min heap data type. Min heap is one of those misunderstood data types because people think, oh, it should be an object, but Python doesn't make it an object. It just makes it a bunch of functions. Get over that. It's actually really easy, right? This is using lexicographic ordering of tuples. So here I have a bunch of pairs, a weight, and an option. I stick that into my heap. What does it compare first, the weight or the option? The weight. Perfect. So now we get to order things using that lexicographic ordering. Almost all of your greedy algorithms will fit this pattern. Start with the first option. Discover new things. Add those to the heap. Keep iterating. Prim's algorithm, Kruskal's algorithm, Dijkstra's shortest path, they all have roughly this same pattern. This is a greedy algorithm. Now, occasionally you'll need a data type that allows you to do backtracking. And in Python, we have this very fancy stack called a list, right? List.append and list.pop implements a stack for you. If you need to find a value in a tree, so here we're doing some kind of depth-first search, we're going to create a stack. We're going to traverse down from a node to some child node. When we get to a child and it's like, oh, this child has no descendants, we need to go back. We're just going to rely on the fact that as we pop things off the stack, we'll jump back in time. So here we're using Python's list to implement a stack. Now, a lot of people will instead implement this using recursion. Anybody ever seen that pattern? You're going to recurse on all of your children. That's an excellent pattern. The one thing you have to watch out for, you're still using a stack. This will trip you up. The interviewer will say, how much memory did you use? You'll be like, it doesn't look like I used much in the function. And you'll forget the stack. The stack is the killer there. I like to write it out this way because it's really explicit how much memory we're using, and it avoids that dreaded recursion error that's a feature of Python. By the way, if you want to switch this from doing a depth-first search to a breadth-first search, what data type would you use instead? You would use a deck. So instead of using a list where you push and pop from the end, use a deck where you add things to the end, but you draw from the front. Right away, you'll switch from a depth-first search to a breadth-first search. It's just that easy. All right, this is, I think, like our fourth one. This is divide and conquer. And Python has a super handy bisect module, which will let you divide and conquer based on the search space. This is built into Python, so you should definitely go and look in the standard library. How does this work? What are we doing? In this case, it's a bunch of scores. We're trying to decide, hey, what grade does each person get? In other cases, when you look at a problem like this, it's going to be some kind of data structure, right? The classic binary search tree is one where you often use divide and conquer. You'll look at the value in a node, and you'll decide, I want to go left or I want to go right. In this case, we're looking at an array, and we're bisecting that array for an index. That's implemented in the bisect module, classic set of algorithms doing divide and conquer. Then it gets more challenging. How many people have ever heard of memoization? Not memorization. See, this is the tricky one. Memoization. Memoization belongs to this category of dynamic programming problems. Dynamic programming, actually the person who coined the phrase said, yeah, that phrase doesn't really make any sense, does it? Because there's very little that's dynamic about it, and of course you're already programming. So why it's called dynamic programming, mostly a misnomer. What we're doing here is we're using a default dictionary. So a default dictionary will automatically create values based upon missing keys. And we're doing a default dict of a default dict. How many of you have ever seen the movie Inception? You remember what they do? They go from a dream into a dream. Here's what we're doing with default dict. We're saying, hey, default dict, when I look up a key that's not there, create for me a default dict. And then that default dict says, hey, when you look up a key that's not there for me, let's go ahead and create an integer for that. Very simple way to create a two-dimensional table. Basically, it's a dictionary of dictionaries. So as we enumerate one sequence and we enumerate the second sequence, we're building a table that says, hey, the current spot is a function of the previous spots. And then we're asking for the maximum value out of our table. This is actually the longest common substring algorithm. It's a classic memoization problem. And what we're doing here is we're kind of building the results bottom up. So we're going from like the very first row, and then we're building the second row, and then we're building the third row, etc. In contrast to bottom up is when you do things top down. And top down, still dynamic programming. We're still doing memoization. But in this case, we're caching things. So in caching them, we're saying, hey, let's start calculating fib of 100. And as we calculate that, we need to go and calculate fib of 99 and fib of 98. So we're starting now with the end goal, and we're working backwards. In that way, it's kind of top down. We're not building up. We're working top down. And LRU cache is going to be our trick. This is inside functools. this is going to cache intermediate results. You need to set max size to none, because otherwise it defaults to 128. And a lot of things that respect caching are going to break down if you only give it 128 key value pairs. Recurrence relations are probably the most complex interview problem you'll face. This is at least my feeling. The way I approach a recurrence relation problem, you have to kind of break it down into a dynamic programming problem, and then you'll realize that your current state space doesn't really matter that much on all the state space that came after it. So what we're doing here is we're calculating the maximum profit you can make from a sequence of prices, but you get to make 2 transactions. So what the last line says here, when we buy one, it says if all you ever did was buy one stock, you would have been out the price of that stock. So that's negative price. But then when you sell one, you get to gain whatever the difference is between those two. And then at buy 2, it's whatever you previously gained minus the cost of that price. And then with sell 2, it's whatever we previously bought plus the current price. Wow, you all understood that on the first description of it, right? No, absolutely not. These things are awful. These are tricky devils, and I sympathize with you. This is a little bit like, anybody ever own one of those really old computers where you plugged in, like, what was that port? It was like an old serial port, and then it would boot up, and it wouldn't find the keyboard, and it would display an error message that said, keyboard not found. Press any key to continue. That's what it feels like, right, to get stuck with one of these recurrence relations. Again, think back to the dynamic programming solution and then see if you can shrink down the state space. That's how I approach these. Most of the time, it's just a set of max and mins, but it is really tricky. I don't have any magic secret for working around that. The last category is finite state machines. Finite state machines are a very common pattern where you're going to either do parsing or you're going to do some kind of processing of input. And as you process the incoming input, you're going to look up that value in a dictionary of some kind, or you're going to look it up in a state space. You're going to map it to some other output, and then you're going to compute a new state space. So what we're doing here, we're calculating, hey, when I see an open paren, map that to 1. When I see a closed paren, map that to -1. That's our mapping. That's part of the finite state machine. And our current state is the count of how many characters have opened parens or how many characters have closed parens. If that ever goes negative, it's not balanced. And when we're done, we want to make sure that the count is 0. So here, for each input element, we're looking up a transition in a map, and we're updating our state. This is a useful tool for complex algorithm problems with multiple scenarios. So you could kind of think of the previous recurrence relation also as a finite state machine, but this is a little simpler to reason about. After all those different kinds of algorithm problems, you're going to get to the object-oriented programming design challenge, right? This one's actually one of my favorites because it's all about trade-offs, and it's often a little more practical. We actually write objects. It's like, oh yeah, I had that real problem in my work. Remember your jargon as you approach an object-oriented programming problem. Remember the 2 kinds of relationships in OOP, is-a and has-a. You got to name drop those things, right? Just be like, oh, I'm going to has-a an attribute here. And they'll be like, ah, very good. They know about this object-oriented programming. You might also mention things like encapsulation, inheritance, and polymorphism. That's generally accepted why we have object-oriented programming. And remember that it's unlikely Python specific. So if you get off in the weeds and you're defining dunder EQ and dunder get attribute, and you're like, maybe a meta class would help here, that is not the right answer. Like, remember that it's probably solvable in Java and C++ and Python. They don't have that. Java doesn't have meta classes. It's not going to involve it. But I would also encourage you to create 2 methods whenever you create a class. Dunder init, obviously, that's how you maintain your state, and dunder repr. That's the only way you're going to debug this thing, right? The dunder repr is our text representation of the object. It is critical for debugging. Whew! That is algorithms in a nutshell. We just went through 10 of them. You're welcome. Yeah, I know. It's like, now you know. It's done, right? You'll go forth and you'll ace all of these. Hopefully the examples give you some time that you can chew on them. You can find other examples online. One of the things you might get to after all those algorithm whiteboarding experiences is they'll actually hand you a computer and expect you to type. You'd be like, what? That's part of this thing too? I actually much prefer coding interviews. That's like my natural habitat. It's like, oh, yes, plug me into the computer. That's how I want to do things. I've got just a couple quick tips for how to do the coding interview in Python. 2 built-in modules are going to be key, logging and doc test. And I know these are more common in phone screens. A lot of companies do this in on-site now too. If you ever put a print, realize that that's not the enterprise-y version. You know what I mean? Logging is the enterprise version of print. And if you're interviewing at a company, that's the language they speak. Speak their language. It's a little bit like when you go to buy like a stick of gum. You know, you might like put $1 on the table, you get a piece of gum. No muss, no fuss. That's print. Logging is like when you go to buy a house. It's like, oh, we're going to have lawyers involved, and we're going to have a framework where we need to talk about things. Where are these log messages going to go? What are log records? Do we want to do structured logging? That's the world of enterprise. Speak their language. What's really nice about logging is that it goes hand in hand with doc test. So if logging emits a bunch of messages, and you don't really want to validate those logging messages, don't worry, doc test won't do that. Doc test is smart enough to go, oh no, we don't want logging stuff. Just show us the right answer. And doc test is actually the best BOGO deal in the valley. This is a buy one, get one free, guys. You're going to copy paste some code from the interpreter where you already saw it working. You'll put it in a doc string, and then it becomes a test case. Wow, right? Like, I don't know how every other language missed this simple feature. It's awesome. Best BOGO deal in the valley. In addition to logging and doc test, I absolutely recommend you go with interactive Python. The IPython shell is your turbocharge when you're facing these things. You can do %run in order to execute your Python file. How does it work? It takes your Python file and types it in for you. Who knew that that would be such a groundbreaking feature? But it is. It's awesome. The one that's really magic is %debug. %debug says, all right, the fit hit the shan, and now we need to go back in time and debug this thing. That's what %debug lets you do. After things go wrong, this is sometimes known as post-mortem debugging. After things go wrong, you'll magically step back in time, and it'll give you a trace back at the point of failure. It'll let you debug what were the variables there, how do I print out the locals, how do I call methods. All of that is possible. Now you can get away with something similar to this pattern by using importlib.reload. You can try and do your print debugging, but if you really embrace these tools, it's your opportunity to show the interviewer that you're not afraid of the debugger, that you know how to work with these things, and they'll love that. They just eat it up. The enemy is anybody who is going to get you killed, no matter which side he is on. Unfortunately, Python has some hazards. There are things in Python that will trip you up. Resist these things. Even though we also have some big guns, you know, like NumPy, right? Someone's like, hey, can you write something that multiplies 2 matrices? If you reach for NumPy, it's kind of like bringing a bazooka to a knife fight. It's like, oh yeah, I can multiply matrices. It's like, okay, that's not really what we were asking though for. So I would encourage you to resist that unless that's specifically, you know, requested. If NumPy is one of the listed like attributes of the job, that would be an excellent thing to demonstrate. Programming interviews often require us to make trade-offs we would not normally make. Let's look at a few of them. This is the one that makes me sad. Variable names. When I'm in a whiteboard situation, I don't give things super long, nice names. When I check code in, I give things super long, nice names because I want to be able to read it and understand what I did 6 months ago. But in the whiteboard situation, I fall back to 1-letter variable names. Now, if you follow a couple of patterns here, it's not that bad. X, Y, and Z, those are your variables. Those are your unknowns. I, J, K, those are your indices. You're going to be looping over stuff. Those are your indices. E is short for elements. D is short for dictionary. Low and high, those are your bounds. L-O-H-I. K for keys, and V for values. Super simple. Always be consistent in using those, and your interviewer will actually really appreciate it. Now, Python has these amazing integers. What's Python's maximum integer? How much memory do you have, right? It's as big as you want to be. So what do you do when you're looking at some Java program and they initialize a value to max int? Oh. Should we just pick like 10 to the 100th? No. We want a number that's bigger than any other integer you could possibly come up with. What do we use? You do not. You actually use float of inf. Ah, floating point to the rescue. Floating point is a little bit like regular expressions. Like the cure is worse than the disease. With floating point, float of inf, did I get it up there? Oh, maybe it's on the next slide. Float of inf is greater than any integer, even if your integer cannot be represented in floating point. What? That's just how Python works, because they recognize, oh, yeah, we need this like numeric data type bigger than any other numeric data type. So we resort to floating point. Division is really fun in Python because we use floor division, and that doesn't match any other language. We're so unique in this way. The other thing we did that was unique is rounding. When you round 1.5, you get 2. All makes sense with the world. When you round 2.5, you get 2. What? This is known as bankers rounding. And bankers rounding is one of those things that's beautiful for air. Mathematicians love it. That's why we adopted it. And every other language does something different. So these things are hazards to you. My other favorite here is 0.1 times 5 equals 0.5. True. 0.1 times 6 equals 0.6. What? And that's because of floating point error. This is a really famous thing. Decimal of 0.3 is 0.299999999. Isn't floating point great? Unfortunately, you're going to have to get comfortable with it because Python's numeric hierarchy expects you to embrace floating point. When it comes to literals, many languages lack the literals that Python has. That means when you want to make a list, you have to call the list data type. They don't have this concept of open square bracket, close square bracket. And if your interviewer isn't familiar with Python, they'll just look at those literals like they're garbage. They'll be like, what are you talking about? Open, close paren, that can't be anything. You'd be like, no, it's an empty tuple. No, that can't be anything. As much as possible, I'd say just use the spelled out name. Call list, call dict, call tuple. I wouldn't check in code like that, but it's easier in an interview. None is also a special case, right? Because we don't actually have this concept of null. You can't null something out. You can replace it with the none object, but none actually has its own type. It's the none type. What else do we see here? Oh, this one's nice too. 1e100. Does that equal 10 to the 100th? No. Floating point has all kinds of weird gotchas like this. So keep that in mind. Float inf, designed to be the maximum integer. Unicode Python strings are different than bytes Python strings. For the most part, if you can avoid talking about these things in your interview, do so. But you're going to need to be prepared. Remember, these are the hazards of Python that might trip you up. I would also say beware any intermediate Python programming tool. I was once in an interview, and I used an else statement on a while statement. So my while loop had an else code block. And the interviewer, with mostly a Java background, was like, huh? You can't do that. And then I had to make a decision. Do I try and teach them something new, or do I just rewrite the code? And I had a similar experience with yield from. I was like, well, actually, I'm creating a generator, and then I'm yielding from that. And they were like, huh? Should I try and explain it to them, or should I just rewrite the code? I think most of the time, just rewrite the code. So you need to have certain understandings of these intermediate topics, know how to break them down. And if you can explain it to them, so much the better. Lots of interview questions require recursion. Recursion story in Python is kind of... So just be prepared for the recursion error. You can change the recursion limit, but if you're getting into that, you're probably off in the weeds. Python actually has its own Zen that I think to some extent says, if you can avoid recursion, do so. I wouldn't fight that. I'd just embrace it. I don't know about you people, but I don't want to live in a world where someone else makes the world a better place better than we do. Anyone know who said that? Gavin Belson, yes, our esteemed leader. Companies are competitive. It is inherent to them. Hiring is extremely competitive. So here's the good news, bad news. The good news of hiring is that it's based on a curve. You don't actually have to be good. You just have to be better than everyone else. Also, an easy tip here, read the job rec and all the recruiter notes. I know that sounds like duh, but I had this experience where in the recruiter notes, I thought this was kind of odd. They said, candidates should be aware of the 4 isolation levels provided by SQL. And I was like, I don't know what the heck those are. I mean, I remember they're important, but I don't know what they are. And so when I interviewed, I thought, well, I should have them memorized, and I'm going to look for that opportunity to name drop these 4 isolation levels, and I'll write out what each one did. And they loved it. Really easy stuff. If they give you a bunch of material to read, read the material. Finally, it costs money to make money. I know this kind of sucks, but that's just the way things work. If you're wondering after all this, oh my gosh, that was fast. I didn't really learn anything. What am I supposed to do now? You should go and invest in this stuff. I spent over $700 in explicit costs, not counting time, not counting all the other resources of practicing with people, just in cold, hard cash. I spent $700 on this. And I did that because I had this experience with my dad growing up. How many people played games with one of their parents growing up? How many people had the experience where it ended in tears? Yes, that was me, because my dad would pummel me. And he would say, you can win at checkers when you're good at checkers. And in that experience, one of the things he taught me, he said, look, Grant, sometimes I offer you a piece, and you go for it, and then I take 3 of your pieces. And I'm like, I know, I hate it when that happens. He's like, so stop taking the one piece. And what he really taught me was he said, look, it's okay to lose a little to gain a lot. And that would be my recommendation to you. It's okay to spend a little money to make a lot more. LinkedIn Premium is absolutely useful. You should absolutely get it. That is in no part influenced by the fact that I now work for LinkedIn. The resume builder truly was very useful. I put all of my stuff on the LinkedIn kind of resume, and then I just deleted different sections depending on the job I was applying for. In-mails were critical. I pestered people. I came up with bizarre and funny kinds of things like, hey, I just got a job offer from Dropbox. Do you want to hire me? That didn't work, so don't try that one. But other ones might actually work. It's also useful to see who viewed your profile. Definitely reach out to those people. Interview Cake is a whole course. I thought it was great. I did the whole thing. I didn't really learn anything new, but it was good to just get into that mentality. They have great walkthroughs. It's a solid approach. Leak Code Premium kind of goes without saying. You can do Leak Code. You can do Geeks for Geeks. You can do a whole bunch of other ones. Here's the insider tip. Questions at companies are standardized. At a lot of big corps, they don't get to make up whatever they want. So if you go on Leak Code, you're going to get a lot of practical questions. Work through all of those. Work through as many as possible. And you know that classic question where they ask you in an interview, what would you say your best strengths are? How many people have ever struggled to answer that? Yeah, you're like, I don't know. I told one interviewer, I'm smart. He was like, well, everyone's smart. I was like, I guess I'm smarter. I don't know how to put it. I discovered Clifton's strengths a little late, but I absolutely recommend it. It will answer this question for you, and it answers it in an analytical way. You want to break the problem into an analytical way? It's going to give you 45 different kinds of characteristics. It'll tell you what you're strongest at, what you're weakest at. That's your ammunition for going into there. And when they ask you what are your weaknesses, you just look at what's at the end of that list. You know what my weakness is? Positivity. I got the lowest score on that. I would totally recommend StrengthsFinder. Invest in all of these things. It is absolutely worth it. I wish you all good fortune in hiring. Go now with Python and get hired. Thanks for letting me share.
So you covered the the whiteboard stage of interviewing. I've seen a lot of companies now, like, just to get an on-site interview, you've got to do HackerRank or those online coding challenges. Do you have any tips for preparing for those besides doing a whole bunch of them?
So I avoided HackerRank. I mean, I think you need to choose your platforms. I do think it's a good platform. So if the companies you're interested in, they're asking for that, I'd say get good at it. But I don't have a lot of experience with that one personally. Sorry.
I was wondering if you had any opinions or advice on negotiations.
Negotiations. Yeah, you should try and get as much money as you can. No, really, the best technique I know for negotiation is to get more than one offer. So, if you look back at that first thing, I got 9 offers, huge range. Lowest offer was like 150. Highest offer was in the 500s. Now, in the 500s, those were paid with future dollars. So you also have to take into account, maybe if I'm paid in equity because it's a startup, that's not the same as like cash from an enterprise. So, I went kind of crazy with that. And I actually, if you've, what's it called? There's like a worksheet web application out there that lets you put in a probability distribution function. And so in one negotiation with a startup, they were like, well, we're going to hand you all of these future dollar shares and they'll be worth millions of dollars. And I said, well, really there's like a chance they're worth millions of dollars and there's a chance they're not. And so I built this elaborate and complex like worksheet that had all these probability distribution functions. The recruiter thought that was weird. She was like, okay, you're supposed to just listen to the pitch and get it. The CTO thought that was awesome. He was like, holy crap, this guy actually broke it down by math. Like, oh, shoot, he knows how much this might really be worth or not worth. So I would say, be yourself. If you're very analytical, go into it with that. Most of the time, remember, they're competitive. You got to get a better offer to improve your situation. But I would always, ask for more. I loved one recruiter. She had this great long talk with me, and then at the end she said, so if you ask for a little more, we can give it to you. And I was like, why didn't you just give it to me, right? I didn't say that out loud. But I went home that night, and I wrote her an email that said, can you pay me more? And then 2 days later, she goes, yeah, absolutely. And I was like, well, okay. So, there's a game. There's like a back and forth. I think there was already a talk today that talked about negotiations. I would defer there. I think that was probably more directly applied. But be yourself. Do your best. Again, remember, it's a very competitive environment. You can use that to your advantage. All right. Thank you for letting me share.